The V12 engine, a marvel of engineering and a testament to human ingenuity. Just the name sends shivers down the spine of any petrolhead. It's not just an engine, it's a legend, a dream for many. It's the pinnacle of internal combustion, a symphony of explosions orchestrated by 12 angry cylinders, each cylinder firing in perfect harmony, creating a melody that is music to the ears of car enthusiasts. Forget your turbochargers and your electric motors. A V12 is pure mechanical magic. It's raw, unfiltered power, a throwback to a time when engines were built with passion and precision. It's the engine that powered legendary race cars and graced the engine bays of the most luxurious automobiles. From the racetracks of Le Mans to the streets of Monaco, the V12 has left its mark. The V12 is an icon, a statement of power and prestige. It's a symbol of excellence, a benchmark for performance and luxury. But how do you build one of these mechanical masterpieces? What kind of expertise and dedication does it take? What goes into transforming raw materials into a roaring, fire-breathing monster? It's a journey that starts with the finest materials and ends with a masterpiece of engineering. It's a complex process, a delicate dance of engineering and craftsmanship. Every part must be perfect, every component must fit together seamlessly. Come with me as we delve into the heart of the factory and witness the birth of a V12 engine. From the first bolt to the final test, we'll see what it takes to create a legend. Our journey begins in the foundry, a place of intense heat, constant noise, and the ever-present glow of molten metal. It's here that the magic begins. In this industrial setting, raw materials such as iron and aluminum are subjected to extreme temperatures, melting down to a liquid state. This transformation is the first crucial step in the creation of our engine block. The sight of molten metal swirling in the furnace is mesmerizing, almost primal. It's a dance of elements, a testament to human ingenuity and the raw power of nature harnessed for creation. The air crackles with energy and anticipation as the molten metal is carefully poured into meticulously prepared molds. Each mold is designed with precision to shape the metal into the desired form. These molds represent the negative image of the engine block, the very foundation of our powerful V12 engine. Every detail is accounted for to ensure the final product meets exacting standards. As the molten metal cools and solidifies, the rough casting of the engine block begins to take shape. This is the first tangible form of what will become a high-performance engine. At this stage, the engine block is far from the polished product we envision. It's rough and unfinished, but it represents the first step in a long and intricate process of refinement and precision engineering. The rough block undergoes a thorough cleaning and inspection process. Every inch is scrutinized for imperfections, ensuring that only the highest quality material moves forward. Only the best will do. This is a V12 engine after all. Each block must meet stringent quality standards before it can proceed to the next stage of production, ensuring excellence in every engine we build. From the foundry's heat, we move to the machine shop, a place of precision and meticulous attention to detail. Here, the rough engine block is transformed into a work of art. Giant milling machines, guided by computers, carve away excess metal. They shape the block with incredible accuracy, creating the cylinders, coolant passages, and oil galleries. Every surface is machined to within fractions of a millimeter. It's this level of precision that separates a good engine from a great one. The slightest imperfection can mean the difference between a smooth-running engine and a catastrophic failure. The machinists here are artists in their own right, wielding tools that shape metal with the delicacy of a sculptor's chisel. At the heart of our V12 lies the crankshaft, a thing of beauty and brutal strength. Forged from a single piece of high-strength steel, the crankshaft converts the linear motion of the pistons into the rotational force that drives the car. It's a complex piece of engineering with multiple journals and counterweights carefully positioned to ensure perfect balance. The crankshaft is meticulously machined and polished, with tolerances measured in microns. Even the slightest imbalance can lead to vibrations that shake the entire engine apart. It's then carefully balanced, both statically and dynamically, to ensure that it spins smoothly, even at high speeds. Section 5. Pistons and rods. The heartbeat begins. With the crankshaft in place, It's time to install the pistons and connecting rods. The pistons, typically made of aluminum for its lightweight and heat-dissipating properties, are the engine's workhorses. They move up and down in the cylinders, compressing the air-fuel mixture and converting the force of the explosion into mechanical energy. The connecting rods link the pistons to the crankshaft, transmitting the force of the combustion. They are made of high-strength steel and are designed to withstand incredible stresses. Each piston and connecting rod assembly is carefully weighed and matched to ensure perfect balance across all 12 cylinders. Section 6. Valves and timing, a choreographed dance. Now we come to the valve train, a complex and precisely timed system that controls the flow of air and exhaust gases in and out of the cylinders. This system is essential for the engine's efficiency and power, ensuring that the right amount of air and fuel mixture enters the cylinders and that the exhaust gases are expelled at the right moment. At the heart of this system are the valves, typically made of tough, heat-resistant steel. These valves must withstand extreme temperatures and pressures, making their material and construction crucial for the engine's longevity and performance. They open and close with split-second timing, allowing the engine to breathe. This precise movement is what enables the engine to perform optimally, providing the necessary power and efficiency for the vehicle. The valves are actuated by camshafts, rotating shafts with lobes that push the valves open at precisely the right moment. The camshaft's design and timing are critical, as even a slight deviation can affect the engine's performance and efficiency. The timing of the valves is critical to the engine's performance. This timing is controlled by a series of gears and chains, ensuring that the valves open and close at the exact right moments during the engine cycle. It's a delicate dance, with the intake valves opening to let in the air-fuel mixture and the exhaust valves opening to expel the burnt gases. This synchronized movement is what keeps the engine running smoothly, providing the power needed to drive the vehicle forward. The precision and timing of this process are a testament to the engineering marvel that is the modern internal combustion engine. Section 7. Keeping cool under pressure. A V12 engine generates a tremendous amount of heat, and keeping it cool is crucial to its survival. This is where the cooling system comes in. A network of passages woven throughout the engine block allows coolant to circulate, absorbing heat from critical areas. The coolant is then pumped through a radiator, where it's cooled by air flowing through the radiator fins. This continuous circulation of coolant keeps the engine operating within its optimal temperature range, preventing overheating and potential damage. With the major components in place, the engine starts to take shape. The intake manifold, a maze of passages, is bolted on, channeling air to the cylinders. The exhaust manifolds, responsible for expelling the burnt gases, are fitted next. Finally, the heart of the beast, the cylinder heads, are carefully lowered onto the engine block, sealing in the combustion chambers. Each bolt is torqued to a specific specification, ensuring that everything is perfectly sealed and aligned. The engine is now a single unit, a marvel of engineering and precision, but it's still a long way from roaring to life. Before it can be unleashed on the world, the V12 engine must prove its worth. It's subjected to a battery of rigorous tests, pushing it to its limits and beyond. The engine is hooked up to a dynamometer, a device that measures its power output and performance characteristics. It's run through a series of simulated driving conditions, from idling in traffic to full throttle acceleration. Sensors monitor every aspect of the engine's performance, from temperatures and pressures to exhaust emissions. Only when it has passed every test with flying colors is the V12 engine deemed ready for its intended purpose. The V12 engine is more than just a collection of metal parts. It's a testament to human ingenuity and the pursuit of automotive excellence. For over a century, it has powered some of the most iconic and desirable cars ever created, from elegant grand tourers to fire-breathing supercars. The V12 engine represents the pinnacle of internal combustion technology, a symphony of power, performance, and prestige. Its distinctive exhaust note, a harmonious blend of mechanical fury and refined elegance, is music to the ears of any car enthusiast. In an age of increasing environmental concerns and the rise of electric vehicles, the future of the V12 engine may seem uncertain. However, its legacy of performance, its status as an automotive icon, and the sheer thrill it evokes will ensure its place in automotive history. Whether it's through hybrid technology, alternative fuels, or innovative engineering solutions, the V12 engine may yet find a place in the automotive landscape of the future, continuing to captivate and inspire generations to come. The symphony of 12 cylinders, it seems, is far from over.